Okay, so today we are going to be problem solving, and basically what that is we're taking everything that we've learned about linear functions and equations and applying it to solve problems we haven't necessarily seen before. Okay, so my learner's question is, how can I use my prior knowledge? Okay, prior knowledge is just stuff I already know. Okay, how can I use my prior knowledge to answer questions? And I'm going to add new questions about linear functions and equations. Okay, question mark. Okay, so example number 1. Which of these 3 sea animals is the fastest? How do you know? Okay, so I have a bottlenose dolphin, a sea lion, and an orca. So if I'm going to be comparing which one is fastest, that I'm going to be looking at slope or the rate of change. Okay, so this says a bottlenose dolphin can travel 8.5 miles every 1/2 hour. Okay, remember slope is for every 1 change in x. Okay, so I have for half an hour, but I need it for a full hour. Okay, so if it's 8.5 miles every half hour, or I'm going to change 1/2 into 0.5. Okay, so if I do 8.5 divided by 0.5, I get 17. So the bottlenose dolphin can travel 17 miles per hour. Okay. Okay, now, if I'm looking at the sea lion, this left side is in minutes. Okay, so if I'm going to be able to compare it, it has to be the same. Okay, so the units have to be the same. So to compare, I'm writing myself a note, to compare, units must be the same. Okay, so when I'm looking here, I need to find where it's 1 hour. Well, 12 minutes isn't an hour. Nope, nope, nope. Yeah, so right there, that's for 1 hour. Okay, even though it says 60 minutes, I know 60 minutes is 1 hour, which means that the sea lion can go 25 miles per hour. Okay, and then my orca, which is a whale, okay, let's see. I don't have an exact point right there. I don't know what that is for sure. Okay, so, and that's the 1 hour. So I'm going to have to pick a point between here and here. Okay, so there's a point and there's a point. Well, this is a proportional relationship. Okay, and when I have a proportional relationship, remember that means that I have a constant of proportionality. Which is the same thing as slope. Okay, slope is not always constant of proportionality, but all constant of proportionalities are slope. Okay, so I'm just going to do, remember, it's y over x for the constant of proportionality because of that 0. Okay, because it's at 0, 0, because if I subtract 0, well, that just leaves me with y over x. Okay, so I have this point, 269. Okay, so I'm going to divide 69 by 2. And when I divide 69 by 2 to find my rate of change, I get 34.5. And that's, again, miles per hour because I took the 69, which represented miles, and the 2, which represented hours, and divided it by 2. Okay, so I divided 69 miles by 2 hours, which gives me 34.5 miles per hour. Okay, so when I'm deciding which one is fastest, I'm going to look at their speeds. Okay, well, 17 is less than 25, so it's not the bottlenose dolphin. Okay, 25 is less than 34.5, so it's not the sea lion. So the orca is the fastest because the rate of change is the biggest. Because its ROC is largest. Okay? Okay, go ahead and do the U try. Okay, example number 2. An 8th grade class wants to hire a DJ for their end of the year party. Write an equation that represents the total cost Y of hiring the DJ for X hours. So we need to write an equation for each. Okay, so remember that's always going to be Y equals MX plus B. Okay, so remember M is my slope, so that's going to be the per hour. And then B is going to be the flat rate. Okay, if there is one. Okay, so DJA, oops, I'm sorry, you couldn't see that. DJA charges $20 per hour plus a $75 setup fee. Okay, so Y equals, so my per hour is 20x, and then my flat rate is that $75 setup fee. Okay, so there's one equation. Okay, DJB, okay, this one doesn't tell me what it is per hour, but when I go from 0 to 1 hour, that adds $40. So that's going to be my per hour. Okay, and then there is no flat rate. So that one's proportional. Y equals 40x. Okay, and then DJC, looks like I start at 50. So that's going to be I have something x plus 50. And then each time it looks like I go up by 25. So 25x plus 50. That's the equation for that one. Okay, A says which DJ charges the highest hourly rate. So I'm just looking at my slope. Okay, so DJB charges the highest hourly rate, and that's $40. Okay. Okay, B says which equation shows a proportional relationship between the number of hours X and the total cost Y. Well, I already answered that. Okay, remember that's in the form Y equals MX. That's what I'm looking for with a proportional relationship. Okay, and that equation right there has that. So DJB is also the answer to that question. Okay, because that's Y equals 40x. Okay, if you only have $150 to spend, which DJ can you hire for the longest period of time? So Y is the total cost. Okay, so right there it tells me that Y is the total cost. So that's where I'm going to plug that 150 in, and I'm going to see which one gives me the most amount of hours, which was X. So I'm solving for X, okay, because X is hours. Okay, so 150, so I'm looking at A first, okay, DJA. So 150 equals 20x plus 75. So remember when I said equations will come back forever. Here it is. Okay, so I'm subtracting 25 or 75 from both sides. 150 minus 75 is 75 equals 20x. And then I divide both sides by 20. And then 75 divided by 20 equals 3.75. So there I could hire the DJ for 3.75 hours. Okay, so that's for A. Okay, what about for DJ B? Okay, if I just plug in 150 equals 40x, so I'm just substituted 150 in for Y right here. Okay, so if I just do 150 divided by 40, 150 divided by 40 is 3.75. Okay, and then DJC is 150 equals 25x plus 50. Okay, if I subtract 50 from both sides, 150 minus 50 is 100. And then if I divide both sides by 25, I get x equals 4 hours. Okay, so I can hire DJC for the longest period of time. Okay, because 4 is bigger than 3.75 and 3.75. Okay, so you can hire DJC for the most amount of time. Okay? Okay, go ahead and do the you try number 2 right here. Okay, example number 3. It says at time t equals 0, a bicyclist begins riding at a constant speed. 10 minutes later, the bicyclist has traveled 2.5 miles. A road worker spilled yellow paint 3.5 miles down the road. So the first question says, after how many minutes will the bicyclist ride through the spill? So let's graph. Okay, so it says they're riding at a constant speed, but all we know, the only other thing we know is that 10 minutes later, they've made it 2.5 miles down the road. Okay, so 2, 4, 6, 8, here's 10 minutes, and then they've gone 2.5 miles. So that's all we know is that that's the information we've been given. Okay, so I'm going to draw a line between those points. Remember, I always like to go to extend it. Now this makes me sad because I don't have 3 points, but that's okay. Okay, so I know that he traveled 2.5 miles in 10 minutes. So I want to find out how far they get in 1 minute. So I'm dividing 2.5 by 10, and that gives me 0.25 miles per 1 minute. Okay, so I'm trying to figure out how long it will take before they ride through the spill. Okay, and that's 3.5 miles down. So if I was going to write an equation for this, it would be y equals 0.25x. Okay, well, or t, I guess they're using t. Okay, for t for time. Okay, so I'm going to plug this 3.5 in for the y because that's my distance. Okay, that's my y-axis is my miles. So 3.5 equals 0.25t. And then I divide. And then I do 3.5, nope, not 3.8, divided by 0.25. And you get 14. So it'll be after 14 minutes. Okay? So it says use a linear function to represent the distance the bicyclist travels per minute. Well, we already did that. Y equals 0.25t. Okay, and it says find the value for the function m equals 25. Explain the meaning of the associated point on the graph of the function in terms of the situation. So if I plug in, and I guess we're using m for miles. Yes, that's what we're using. We're using m for miles. I apologize. So m instead of y. Okay. Okay, so if I plug in 25 equals 0.25t, okay, so when I solve this, 25 divided by 0.25 gives me 100, okay, so the point is technically 125. Okay, so remember 25 represents miles. Okay, so this means that in 100 minutes, the bicyclist will be 25 miles from the starting point. Starting point. Okay, so if this is my t and this is my miles, so this is time in miles, that's 100 minutes and 25 miles. Okay? Okay, go ahead and do the you try. Okay, last example. A gardener collected 40 gallons of rainwater in the tank. Later, the bottom of the tank cracks and the water begins to leak out. The water leaks at a constant rate of 2 cups per minute. Okay. The gardener notices the leak after an hour. She needs 30 gallons of water to water the vegetable garden. Is there enough water in the tank? Okay, so we have to figure out how many cups are in a gallon. Remember, I can't compare until I know that. Okay, so Miss Hart actually has to Google that. I should know that. I think it's 16 cups in a gallon. Give me just a second. part was right. Okay, so there's 4 cups in 1 quart, and then there's 4 quarts in 1 gallon. So it takes 16 cups to get to 1 gallon. Okay, so that means that it would take 8 of, so like if it's leaking out 2 cups per minute, after 10 minutes, okay, that would be 20 cups. Okay. And then after 20 minutes, that would be 40 cups. Okay, so let's see if either of those gives me nice amounts of gallons. So 20 cups, and there's 16 cups in a gallon. So 20 divided by 16, you can't see that, is 1.25 gallons. So if we've doubled that, that's 2.5 gallons. So if after, this was after 10 minutes. So I'm trying to draw a graph. Basically, sorry if you're confused. What I'm trying to do is I'm trying to make a graph that goes down because I know it's leaking, okay? So after 10 minutes, 20 cups had gotten out. And so I was trying to figure out how many gallons that was. So I divided it by the number of cups in 1 gallon and got 1.25 gallons. But if I do 40 cups divided by 16 cups, that would give me 2.5 gallons. So after 20 minutes, I've only lost 2.5 gallons, which if I do 40 minus 2.5, that gives me 37.5, which would be right halfway between 35 and 40. So I'm right there. So I haven't lost very many gallons. Okay. So if I flip this on over, I'm just going to flip this over here. I'm going to draw a line. Okay. So what this says is the gardener notices the leak after an hour. Well, that's 60 minutes. Okay. So she needs 30 gallons of water to water the vegetable garden. Is there enough water in the tank? So 60 minutes is an hour. Okay. Well, we know it's 2 cups per minute. So if I do 60 minutes times 2 cups per minute, okay. Oops, I'm sorry, you can't see that. That's 120 cups that we've lost. Okay. Well, if I do 120 cups divided by that 16 cups, let's see how many gallons that is. 120 divided by 16 gives me 7.5 gallons. Okay. So that's 7.5 gallons. So that means that I started with that 40 and I've subtracted 7.5, which leaves me with 32.5. So if she needs 30, so we started with the 40 gallons and we lost the 7.5 gallons, which left us with 32.5 gallons. So if she needs 30 gallons, is there enough water? Yes, there is. There is enough. Okay. Okay. U-try number 4 says, after how many minutes is there no longer enough water in the tank to water the vegetable garden? Okay. So you're trying to figure out when is it going to reach that 30 gallons, I'm sorry. Okay. So find how many minutes before it's less than 30 gallons. Okay? Okay, that's it for today.